So students, as we have discussed in the previous session about the typical running time functions which are associated with various algorithms, like in different algorithms we might have constant running time, logarithmic, linear and so on. So let us continue further. Next is criteria of measurement, and a function can be defined as based on these three things like worst case, average case and best case. These are basically the different situations under which an algorithm can be identified based on a function or represented by use of this fn function. So worst case represents the worst case time complexity of an algorithm, average case represents average case time complexity, and best case represents best case time complexity of an algorithm. So how we define them? In case of worst case, it is basically the maximum value of this function fn for any particular input. So in this case we can say that it is total number of maximum steps that an algorithm can take for any collection of data values in order to complete the process. So any algorithm which can be completed in the maximum number of steps for any particular algorithm, so that can be said as the worst case running time of that algorithm. Means in this much amount of time the algorithm should complete maximum time. So that is the worst case, and it is associated with maximum number of steps. If we talk about average case, it is average or expected value of this function, which is taken based on all possible inputs and we take the average on it, and its efficiency is defined as based on all the average possible input values. Based on this we have to analyze, like if a function takes if an algorithm takes this much amount of time for suppose 10 inputs and some amount of time for 20 inputs, some amount of time for 30 input values. So based on that we need to take the average and we can calculate the average case complexity. In case of best case, means it says that minimum number of steps the algorithm can take for any collection of data values. Means for any collection of data values, how much minimum number of steps the algorithm will take and complete its task. So that is the limited, or you can say the minimized amount of time. So what is the minimum value of this function fn for this n taken as the collection of data values for that algorithm to be completed in a minimum amount of time? So that is represented as best case. And further, when we discuss the asymptotic notations, this worst case will be represented with Vigo notation, something which is being discussed in the coming session. Then we have this average case, which is represented with the theta notation, and then we have best case, which is represented with the big omega notation. So let us continue further. This algorithm complexity and the criteria of measurement. Suppose we take the example for the previous scenario. So we take this algorithm linear search, means we are going to search linearly based on the given number of elements. Suppose this is the array which I have taken. Inside this array there are some elements, and out of which I have to search one particular element. Suppose this is 1, this is 2, this is 3, 4 and 5. Suppose these are the number of elements which are present in this linear contiguous array, and we have to search for an element, suppose this 5. So what will be the running time that we have to calculate in case of worst case scenario, average case scenario and best case scenario? So इस algorithm को ये searching complete करने में, जिसमें मुझे एक element search करना है, that is 5, how much time it will take? So as per the linear search algorithm, what we will do is we will take this value 5, which is the search value, and we have to compare this first with the first element, then second element, then third element, then fourth element, and so on till the value matches with some particular element in the array, or there is no match at all. So based on this the linear search algorithm works, and when it searches or find out that search element present in the array, it will return its location, or we can print a message based on our algorithm or program. So in case of worst case, what we can predict is item will be at the last of the array, or there is no item present with the same value. Means suppose I am searching for value as 6, so that means 6 should be inside this array, but if I traverse this array one by one, element by element, so there is no such element present in the array. So it will be the case in which the worst case scenario where the element is not found, or if it is found, it is at the end of the array. Suppose this 6th element is present here and it is at the end of the array. So that means how it is worst case, because we have to search here first, then we have to perform second comparison, then we have to perform third, fourth, fifth, and as per the number of elements or as per the size of this array, maximum size of this array, we have to perform that much number of computations or that much number of comparison operations. So that will be the worst case running time. So if we talk about worst case running time, it is based on the number of inputs which are present or number of elements which are present inside that linear search based array. So that means it can be having the function as f of n should be equal to n. In average case, we have to take the comparisons based on the average of those search operations. Suppose I am searching initially for 6, then maybe I will search for 2, then later on I will search for 3, and so on. So based on that, I have to find out the time for every particular situation and then take the average of everything, and that will give us the different value. So that is the idea of average case. And in case of best case, what I can say is the element is figured out at the first location itself. Suppose I am searching for the value 1, so 1 is already present in the first location inside the array. So I can say that it will give me the best case running time of the algorithm. So that means the total number of comparison operations or the you can say search operations are minimized to 1. So that is the best case for this linear search. So that is how you can relate worst case or worst case, and average case and best case time. Then next is your big O notations or asymptotic notations. So under this asymptotic notations, first one is your big O. So basically, what is asymptotic notations? These are the notations which we use to make out the relations between the functions running time, and based on which we have to calculate the worst case or average case or best case scenarios of different algorithms. So these are some notations based on which these algorithm complexity can be measured, or you can say bounded. So first one is the big O notation, which is giving us the least upper bound. Least upper bound we'll discuss later. So we say that the function fn is bounded by some function gn. If it is so, we can say that fn is equal to big O of this particular gn function. So what does that mean? It says that the function should be less than equal to some constant c multiplied by this gn function for all values of n. Make sure that n is greater than equal to n naught and c greater than equal to greater than 0 and n naught greater than equal to 1. So based on these conditions, our function should be less than equal to some constant c multiplied by the gn function. So if we are able to find out a function gn multiplied by some constant c which is always greater than equal to after this value of n, that is after the value of n naught, the function will be always greater than fn or equal to fn. So this c, it is a constant which we are saying, which is a multiplication factor which we use, and it should be greater than 0, and n naught is greater than equal to 1 because there must be some input value, at least one input should be there based on which I want to find out the big O notation. So big O notation is moreover related with the worst case running time of an algorithm, like how we identify that in worst case scenario how much running time the function will take, so that we have to bound. So let us represent it with the help of a diagram first, and then it will be more clear. Suppose this is the representation function, and these functions are represented in the figure like this. So this x-axis represents the number of inputs, and this y-axis represents the time, running time, that is represented by t. I'm not discussing about the time units like milliseconds or anything. So what I'm saying is, if suppose I'm saying that a particular algorithm, based on the increase in the number of inputs, what will be the amount of time it will take for completion. So suppose for a particular algorithm, the running time is represented by this fn function, and the graph for that fn is like this one. And what is the big O of this particular fn function? Big O is basically a function multiplied by some constant. which after a particular input will always be greater than equal to this fn function. So that means इस n नोट की particular value के बाद it can be any value. After this particular value, this function multiplied by c will never be less than this fn, or we can say that fn is always less than equal to this c multiplied by gn after this value of n naught. Okay, so if we are able to figure out this function, then we can say that that is the big O of this particular function fn. मतलब वो एक fn का big O है. Big O means it is bounded by that, or it is greater than that particular function after a certain value of input which is provided to that algorithm. उस algorithm को एक input values जो हमने दी हैं, एक particular set of input value के बाद जो भी उसको input values मिलती जाएंगी, हमेशा वो function उससे बड़ा मिलेगा. So that is how we are able to figure out the bound. अब ये bound किस लिए जरूरी है? Because we want to predict what is the maximum amount of time that the algorithm can take to complete its operation. That means we are moreover talking about the worst case scenario. So that means worst case can be represented by this particular asymptotic notation which is big O. So एक function से हम उसका big O find out करते हैं तो हम worst case time उसका basically calculate कर रहे हैं. So suppose I am saying that fn is big O of n square. It is big O of n square. That means fn should be less than equal to c multiplied by n square. Okay, so less than equal to c multiplied by n square. So equal to should be there, and so fn can be larger than n square times, but we can choose some constant c and some value of n naught such that for every value of n larger than n naught, means n naught के बाद जो भी n की values होगी उसके लिए ये हमेशा less than equal to cn square रहेगा. So that is for larger value than n naught, fn is never more than a constant multiplier greater than n square. So हम ये कह रहे हैं कि function does not grow more than a constant factor of n square after that particular value of n. मतलब उसके बाद वो से ऊपर कभी grow नहीं करेगा. ठीक है, so we are bounding this fn function by the value of n square multiplied by some constant. Next is our example for big O notation. How will performing these operations? What is the meaning of big O for this particular function? Suppose we have running time of a function as 2n plus 3, and we need to find out this c and gn for this particular fn function for a particular algorithm. So as per the big O notation, the representation between this will be like this, like fn is less than equal to c of gn. So this will be fn, this is c and gn, and this is the less than equal to sign after we convert this into required formula. So let us take the value of this constant c as 10 and gn as the value n. Why we are taking here as n? Because we are saying that if n is less than n square, so I should not be choosing left and right side of different order. Order मतलब यहाँ पर n की power 1 है, and here we have the power of n as 2. So based on this we are saying that the order of these two sides are different. This is having order 1 and this is having order 2. So if we are comparing two terms based on different orders, so there are chances that most of the time the higher term will be always greater than the lower term. So what we are expecting is, we are expecting that fn and gn function should be of the same order of n, means input क्या same order की हम बात कर रहे हैं, मतलब यहाँ पर भी n का order 1 है और यहाँ पर भी n का order 1 है, raised to power 1 है. So that is the meaning of the same order. So we are taking generally like gn equal to n. If we have taken n square, so n square will always be greater than n by some value, but we are finding the least upper bound. Why we are talking about least upper bound? Because I am saying that if this function is, we have figured out this gn which is greater than fn, so there might be some other function which is like this, and this is also having the same relation, like fn can be bounded by this function also, this new function. So how we predict this big O of a particular function if we have more than two functions bounding it? So we have to take the least upper bound. Least upper bound में क्या होगा? This will be the function. So this is the correct function which is the least upper bound. After this, we can say that it can be bounded by some higher functions also. So we are concerned moreover about the least upper bound. That's why we are taking that, we are only taking the same order of functions on both the sides. So 2n plus 3 as per this formula will be less than equal to n. Suppose the value of n, that is n naught, is 1. So in that case it will be 2 plus 3 5, and on this side it will be 10. So 2 plus 3 5 should be less than equal to 10. So that is the condition that we have figured out. So that means this is true. So we can say that this 10n can be our required value of C and Gn. But if I say so, I can figure out some other values also, because this 10 I have taken randomly. This n I have taken based on the logic, like they should be of the same order, but this 10 I have taken randomly. So suppose if I take some value less than that, and C should always be greater than 0. So it should be a positive number. So if suppose I take the value of C as 5, so how it should go? Like, if for the value of n greater than equal to 1, if I put this value n equal to 1 here and 1 here, so both sides will be 5 less than equal to 5. So condition is again true, and we are able to figure out the better option as compared to this 10n. So the idea would be how to choose this value, basically कि लेफ्ट हैंड साइड पे जो वैल्यू है फंक्शन की, राइट हैंड साइड पे कैसे इक्वल हो पाएगी, या फिर कैसे उसका फंक्शन चूज करना है, हाउ टू चूज दिस C and Gn. It is based on this particular thing. Suppose for same order value, what I can do is I can write this thing, 2n plus 3 should be less than equal to, on the other side also what you write is, in order to identify what is the value of C and what is value of Gn for a particular function, what you do is you write this thing, same value on both sides, and associate n again with the constant value. So it will become 5n. So as you can see, 5n is the better option as compared to the 10n for a particular value of n. So this is how we can predict. This is one of the shortcut method you can do, but you have to make sure that both the sides should be of the same order of n. n का order change नहीं करना, otherwise things will not work.